Hi guys, Alex here, and today I'm gonna discuss about the very basic concepts of big O notation. And what is big O notation? So in its essence, big O notation is a powerful tool used to express the efficiency of algorithms, not in seconds or minutes, but in terms of how their performance is affected as the amount of data that they deal with grows. So in this video, I'm not cover all types of big O notation. I'm gonna take just three examples. I'm gonna cover constant time, logarithm time, and linear time. O1, O log n, and On. So the n on big O notations in here, as we can see, is it represents the number of operations required with n being the size of the input dataset. And the O is just like kind of ID to identify big O notation. So let's go to our first example in here, O1. So O1 is constant time. So no matter how big my array is or my list is, the time to perform or the steps taken will be the same. It's like a random access of an element in an array or returning a value from a function, like using a console.log in JavaScript, for example. So no matter how big my list is, it's just instant. The second example that I'll cover is ON time, linear time. Linear time, which, as we discussed in the previous video about binary search, is represented by ON. Simple search is represented by this in big O notation. So as my data increases, the size of my array or list increases, the steps taken will be the same, will be the linear. So this is not efficient. This is not an efficient algorithm, because if you have a list of a million of elements, in the worst case scenario, if your target value was at the end of the list, as we said in the previous video, it would take like a lot of times or steps to run the algorithm. And an example of this is looping through elements in an array. So you're going through every element until you find your target value. And finally, we have O log n, logarithm time. So an example of this is binary search. So as our data increase, as our array increase, the time doesn't grow as much as On because we always dividing the search that we're doing. So every time that we're going through some piece of information, like in binary search, we are dividing and dividing. So O log n is inefficient. It's an example of an efficient algorithm. So this is the very basics of big O notation, guys. In the future, I will cover some topics like sorting algorithms, like hash tables, and we're gonna see more examples of big O notation in there. So to wrap things up, remember that big O notation is a tool for analyzing algorithm efficiency. Whether it's O log n or On, understanding these complexities empowers us to write more efficient code and tackle larger problems more efficiently and effectively. So as I said, in future videos, I'll give you more examples of types of big O notation. For today, that's it. So thanks guys for watching, and I'll see you in the next video.